Hello there. So this is going to be an exciting couple of lectures. We have one on heaps, and then we're going to see heaps on steroids, and that's going to be called a Fibonacci heap. So this is a really fun lecture to give. I think this is the first data structure that we get in this class. So we focused most of our time so far on algorithms, and this will be the first time that we do a real deep dive into a data structure. So let's just start by talking about why are we talking about data structures. So not probably surprisingly to anybody, but we use data structures in pretty much every single programming task that we do. So as software engineers or programmers or researchers that are using programming for whatever we're doing, we're going to be using data structures for pretty much everything that you can think of. So let's just start with some examples of data structures. Among the data structures you already know might be heaps, but we are going to still cover this probably in a little bit more detail than you saw in your data structures class. The next thing to think about are what are some of the use cases of these data structures. So I'm just going to put a pause in the video here. You don't need to write anything out, but I just want you to think of the data structures that you've come up with in the previous question, and just think about how you've used those in your program so far. So what do these applications you've had in mind, what do they have in common? So what are data structures good for? They basically organize data so that we can effectively access it. And we can access things in different ways. So sometimes we'll need to have constant time access to any element. Sometimes we'll need our data in sorted order. Sometimes it doesn't matter, we just want to loop over the data and it doesn't matter the order. So a data structure is not necessarily just a method for laying out in memory, but that's part of it. But really, it's better to think about a data structure as just a logical way to think about and reason with your data and apply algorithms with a certain data structure. So the first one we'll talk about in this class is called the heap data structure. And we'll soon talk about stack and heap, like the C memory model. So I do want to emphasize that this is not sort of the heap that you think of when you hear something like a heap allocated chunk of data. This is a data structure that has a very specific definition for it. It's a container for objects that have key values, and sometimes we refer to it as a priority queue. It's a data structure that doesn't do a whole lot of different operations, but it does these very well. We have an insert, and it takes logarithmic time to insert into a heap. We have an extract min operation, or if you have a max heap, it's an extract max. And that also takes logarithmic time. There's an operation normally called heapify, which lets you insert n elements in big O of n time. And you'll notice that would be cheaper than just calling insert n times. Because we have to do, and that would end up being n log n. So heapify is just a more efficient way to insert a batch of items. Arbitrary deletion. So let's say we have access to a node. We don't have to search for it, because searching for something in a heap is going to be a linear time. But to delete an arbitrary node is going to be a logarithmic time. So what is it good for? You really just want to use it for continually getting a minimum or maximum element, and that's pretty much it. And when we start talking about Fibonacci heaps and Dijkstra's algorithm towards the end of this lecture, and definitely in the next lecture, I'll introduce another operation called the decrease key operation. But that's not something that'll show up a lot in this set of lecture slides.